AISUS is headquartered in Aberdeen and has been established since 2012. AISUS is a specialist inspection company, and we focus very much in offshore structures and in the splash zone. Inspection happen on these platforms by rope access teams hanging down from the platform, coming down to the water level. Normally that 10 meters above the waterline is quite a tricky part because you've got the wave impact coming in. There is also subsea inspection campaigns. These are done with ROVs and a vessel in the field with the ROV working off the vessel. That area of -15 down to the water level is again quite a challenging area to be inspected due to the waves and for ROV to be able to keep stability in that area. That's kind of the area that we've carved out for ourselves as being the specialists. The structure will over a period of time corrode. So because of that, quite a lot of maintenance and inspection is required. What makes AISUS unique is the robotic solutions that has been developed 10 years ago. We have got specialist tooling that can either go internal to pipe work to inspect it from inside where we protect it from the environment, or alternatively systems that is actually magnetized to the pipeworks that is gathering vast amounts of data in a single deployment. That is not just images, but also the ultrasonic data.
I received an email from one of their members of staff about a paper that we published some time ago. Now it seems that research paper was related to one of the problems they want to solve. So that really what started the discussion.
We, as a company, realized that we've got all this data, but we didn't know how to use the data or what methods was out there to do it.
The main objective of the KTP program was to automate this process, powered by computing vision system and deep learning based methods. Basically what we did was training the model from all the data set that was already pre-processed. What we wanted to do at this stage was to see how the model predictions differ from the actual knowledge of the senior engineers. We started with an accuracy of 75% in detecting circumferential welds defects, through wall defects, cracks, and material loss. Currently our model has an accuracy of 92% of detecting all these defects.
One of the big changes for us was, we've had this drive on image classification, and for that we need quality images. It was a risk taking the 360 camera because that's never been deployed in an offshore environment, and more importantly in a subsea environment. That has also allowed us to stitch images together, create 3D models, create virtual reality experiences for our clients to actually use the VR headset, put them inside these casings to really understand what the degradation is and to be able to see it, overlaying the ultrasonic data into that same environment, which really helps engineers to make informed decisions because they've got all the data. Our inspection engineers like to go offshore and collect the data. They don't necessarily like to sit 5 days in front of a computer to review 950 images from a job that they've just done. Louis streamlined that process for them and makes it so much quicker and more efficient.
Currently we're working in the deployment of an API tool and basically an application program interface that the engineers could easily interact and integrate for the generation of the reports. What this allows us is two things, is giving all the teams, the project lead, a way in where they can see and visualize previous report and historical reports based on that to assess and evaluate the tools that they may need for the next inspection, and also to the client to start more discussions about how we can inspect similar components that are really close to one that probably has a lot of degradation.
Our clients are having different conversations with us, which keeps us at the forefront of our competitors. It's the mindset shift that we've seen from just being an inspection company to actually we are now industry leaders in advanced technology around data, around image classification, and that's very valuable for us going forward.
Clearly there is several case studies out of this KTP that are already used at the university for teaching purposes. The data that we work with and was a result of this collaboration provided an excellent opportunity for our undergraduate students. Lewis has been transformed literally during the last 18 months. I'm really impressed about the amount of technical knowledge and ability he developed and successfully applied within the company, but also his confidence as an independent researcher. He has one paper accepted to appear at an international conference and hopefully another article before the end of the year. Without the support of the North of Scotland KTP Centre, I probably would say it would be extremely difficult to progress KTP projects at RGU and beyond. Their role is absolutely crucial in terms of bringing the partners together, championing the way we collaborate with the industry partners.
You only know what you know, and it's only once you start and put a dedicated resource to a project like this that you actually realize how many more things we can do. And we're now looking at corrosion rate analysis, looking at different regions, looking at how corrosion rates and the data that we've got can help influence future designs for offshore wind, for renewables, for what the future of energy is going to look like in an offshore environment. Yeah, it's transformed us. It's transformed us as a business.
Knowledge Transfer Partnerships, or KTPs, are unique collaborations that drive innovation and create positive impact. Each KTP enables a forward-thinking business to partner with one of the UK's world-class knowledge bases. Together, they develop and deliver a strategic innovation project led by a talented graduate known as a KTP Associate. At least 50% of eligible KTP costs are funded by Innovate UK.